Today we review quadratic functions. There are two forms of a quadratic function, but first of all you need to know that when you see a quadratic, you're going to get the graph of a parabola. The first form of a quadratic function is y equals ax squared plus bx plus c, and the other form, vertex form, is called y equals a times the quantity x minus h all squared plus k. Both forms give us a lot of information about the parabola. Form, and y equals ax squared plus bx plus c, that's our standard form of a parabola. When a is positive, my graph opens upward and has a minimum value for a vertex or turning point. When a is negative, it opens downward and has a maximum value as a vertex or turning point. The c value, the constant term at the end, is the y-intercept, or starting point, or initial condition. And the line x equals negative b over 2a is the axis of symmetry, which I abbreviate to AOS. In vertex form of my parabola, a represents the same thing, how it opens, and the vertex is the point hk. Notice the sign on h changes from its equation, and k stays the same. So the other thing I want to discuss is solving quadratic equations. There are four ways you can solve. First is to factor. You factor your quadratic, set your factors equal to 0, and then solve each factor. A second way of solving is by graphing. After you graph, you look at the x-intercepts, which are also called zeros. A third way to solve is using the quadratic formula. Remember, the quadratic formula is given to you on your Regents reference sheet, so you do not need to memorize that anymore. And the fourth way to solve is by completing the square. We'll solve by factoring and graphing today in detail. When we do our quadratic functions unit, we'll review the formula and completing the square for solving. But today, let's review solving by factoring and graphing. So, for example, I may ask you to solve x squared minus 7x minus 30 equals 0. So I can factor that. I need two numbers whose product is negative 30 and whose sum is negative 7. Those numbers are negative 10 and positive 3. So I rename my negative 7x to negative 10x and positive 3x to split the middle using the product sum and take a greatest common factor out of both sides. The left side becomes x times x minus 10. The right side becomes positive 3 times x minus 10. So I can see my common factor is x minus 10. My other factor is x plus 3. Now because I'm solving, I set each of those factors equal to 0 and solve each equation. So here x is equal to positive 10 and x is equal to negative 3. Now let's solve the same quadratic by graphing. So on your calculator, you'll enter x squared minus 7x minus 30 at your first function. But you should understand what's going to happen first. It's an upward opening parabola because a is positive. Your y-intercept is negative 30. That's your c term, so we'll need to adjust our window. And the axis of symmetry, x equals negative b over 2a, will be x equals 7 over 2. So x equals 3.5, or 7 halves, is your axis of symmetry, the line that cuts your parabola in half. So let's go to our graphing calculator, or Inspire. Okay, so when you graph, you can either make a new document or just use your scratch pad to do a quick graph. Since this is nothing we'll save, we'll just use a scratch pad. You want to go to a scratch graph page and enter your function. So our function name is x squared minus 7x minus 30. Now when we graph that as expected, we don't see the y-intercept because it's negative 30, so we need to adjust our window. Now as a reminder, using your Inspire, you can click on any of your axis labels and double click to edit them. So I'll first change this to negative 30, my negative y value, and hope that I get to see more of my graph, or negative 40. And I'm going to tab instead of pressing enter to make adjustments. It just saves me a little bit of time. So that negative 40 wasn't quite enough. And I'm going to change my positive x to positive 15 instead of 10 to see more of that. And maybe my negative y value should be negative 50. And that's good. I can now see all of my graph, or enough of my graph to see all the features. So I push enter to keep that window. Now to check the zeros, remember there are x-intercepts, and we can eyeball it and say it looks like it's positive 10 and negative 3, but we always want exact values. So to get those, we'll press Menu, Analyze Graph, 0. Remember our x-intercepts are also known as zeros. It's asking you for a lower boundary, and your hand is attached to that line. Lower means left, so we'll go to the left of that 0. Menu, Analyze, 0. Click to the left of the 0 you care about, and then it changes to upper bound. Click to the right, and there's your first 0. X is equal to 10. You need to repeat the process for your other 0. Menu, Analyze Graph, 0. Move your hand to the left, and then to the right, and there's your other 0 of negative 3. So my zeros match my graph, or match my factors when I factored it. Just for the sake of reviewing how to use your Inspire, we can also find the vertex or turning point of this graph. It's a minimum, so I can go to Menu, Analyze Minimum, and just like with a 0, you need to choose a lower boundary and then an upper boundary, and it labels your minimum point for you. If you can't see it well, you'll want to move a label out of the way by clicking and holding and dragging. Shift click in the middle of your touchpad closes that hand for you, and you can see that the vertex is 3.5 and negative 42.3. Again, we didn't need that for the problem to solve, but it's nice calculator review. The last thing I'd like to review with you today is how to change an equation from standard form to vertex form by completing the square. So we'll review the process of completing the square from algebra. Now when I look at this equation, I know that my parabola opens upward and the y-intercept is positive 7, the point 0.07. And I can take that b value and plug into x equals negative b over 2a and get x equals 8 over 2, or x equals 4 as the equation of my axis of symmetry. It's a vertical line, it needs that x equals attached. But I'm curious about what the vertex is, and I want to review completing the square in order to get an equation in vertex form. So the process of completing the square, the first step is to get the c term, the constant term, out of the way. So here I'll subtract 7 from both sides to move that positive 7 over. And then I make what I call the b list. I write down my b value, here it's negative 8. I take half of that, half of negative 8 is negative 4, and then I square that half b term. Negative 4 all squared is 16. I do that because now when I add that half b term, half b squared term of 16 to both sides, my right side is now a perfect square trinomial. It's a perfect square. I've completed the square. I've made a perfect square. So I can now rename that as the quantity x and your half b term minus 4 all squared. Those are equivalent expressions. Clean up the right side. Negative 7 plus 16 is 9. So I have y plus 9 equals x minus 4 all squared. But to graph I get y alone. So now I'll subtract 9 from both sides. And the vertex form of this parabola is x minus 4 quantity squared minus 9. So now by looking at that equation, I know quickly that the vertex of that parabola is 4, negative 9. That's good news because the axis of symmetry is x equals 4, and the axis of symmetry always goes to the vertex or turning point, so those numbers need to match every time.